In this video, we're going to look at two special piecewise functions, and the first is the absolute value function. Now, you've probably seen the absolute value before, but you may not have seen it described in terms of a piecewise function. As we say, the absolute value, if the number is positive, we keep it positive. So if my x is a positive, or 0, we keep it as is. However, if we have a negative number, so here if I have a negative, it's negative x. So think of, because if I take, so here if I do f of negative 2, using this as a piecewise, that means I'm doing that one, but the negative of a negative is positive, and so yes, it still works out, but that negative drops out. We can also do this graphically. So we've got x if x is greater than or equal to 0. So starting here at 0, let's draw my x graph. And I am including 0, so I've got a nice little point there. And then the negative part, I've got negative x, which looks like that. And we do then get that V shape, which is our standard absolute value function. So that is, think of that as the formal way of writing absolute value. And now that we know piecewise, we can express it in that form. The other function I'd like to touch on is called the greatest integer function. It's also sometimes called the staircase function. It's also sometimes called the floor function. Now there's a couple notations. I'm more familiar with this notation where it looks like the bracket, but we've only got the bottom. This is also a notation that we might see, and in the textbook I'm using, that's the notation you'll see in the textbook. What this means is we are basically cutting off the decimal. So if you had f of 1.2, we're going to get 1. F of 2.9, we're going to get 2. Always be a little bit careful with the negatives. So f of negative 0.1, I'm not getting 0, I'm going down, so I would get negative 1. So again, we are essentially cutting off the decimal. So what we're going to get is at 0 we've got 0. And then we're going to go to 1. We've got a flat line there. And then I'm going to draw another flat line, basically from 1 to 2. So you'll notice at 1, we're including 1. And then at 2 there, I've got the 0. Because at 2, we're then going to hop up here and get that to 3. And we will have similar going the other way. We'll have an open circle there, a closed circle there. I am not the best artist, so I apologize for the bad artwork there. But that is basically what our function is going to look like. You can kind of see why we call it a staircase. It looks like we're climbing stairs if we go from left to right. We also call this the floor because we're going down. There is another function called the ceiling, where we always go up. Here, because we always go down, that's why we call it the floor function. So here, I just want to see the graphs and to have at least some idea of how these functions work.